Good morning, dear students. Welcome to another session of Introduction to Data Structures and Algorithms. In previous sessions, we started off with the discussion pertaining to recap of C programming. So, in that, we discussed regarding decision constructs and looping constructs. Uh, so, we discussed regarding programs pertaining to the constructs what we had seen previously. So then we saw what is meant by array, and we saw what is single dimensional and multi-dimensional array, how we can declare and initialize an array. Then we looked into strings. So as we mentioned previously, string is nothing but an array of characters, and since it is an array, what happens is each of the characters is stored in the continuous memory location. And as we had seen that the last character of a string is always a null character. So we should remember that when we have allocated, say, some three memory locations to a character, to a string. So in that, generally the maximum number of characters what you can store over here is two characters, because last character will be a null. Maximum of two characters you'll be able to store, and including the last character, which is always a null. So minimum, you can have, say, one character, say something as h over here. If only one character is there, then the next location will be a null character. But if two characters are there, then this location will be a null character. Now by mistake, if you have assigned something like this, if you have done like this, but only three memory locations are available, then what will happen is h and e will be stored in these memory locations, and last memory location will be stored with a null character. So this is one special case of the strings. So when you're using strings, you should be taking care of these aspects, say either logically or in your program, this thing you have to take care of these aspects. So we saw how we can declare the strings. We can declare the strings. So that is the syntax. You specify the data type, string name, and you specify the size, that is how many characters or how many contiguous memory locations you require over here in the square brackets. And if you want to initialize it, you can initialize it here itself. If you want to initialize a string, you have to put it in the double quotes. You have to put it in the double quotes, and you specify the details of the string. So here, as we had seen yesterday, the data type is character. So this is a array of characters. str is the name, and it can store around 10 characters. In that 10 characters, maximum of 9 characters can be stored, plus one null character can be assigned. But here, if you just see, you have allocated 10 memory locations, but how many you are using? 1, 2, 3, 4, 5. So only 5 characters are present in this string, and sixth location will be stored with the null character. Maximum I can have 10 characters in a given string, including the null character. So here I have 5. So this will be stored in this, but the next memory location in this str will be stored with the null character. Now, what are the string functions which I can utilize to input and output the string? So here I have input and output string functions, which is termed as getS and putS. So how do I utilize this? The name itself get specifies that this is getS. So it will accept the string from the input console. It will leave the say the white space characters. Suppose if I have written something over here as hi, then I put a space and then I write hello. So what happens is there is a space over here. Space, tab, enter, these are all white space characters. So another specialty of string is that it will exclude all the characters after the white space. So only these two characters will be stored in this. It will not be all these entire characters. Only these two characters will be stored, and next location, that is After 0th index and first index, the third index will be stored with the null character. So this is another specialty. So getters actually receives the character strings from the input console. So how do I utilize it? Within the function, it is an inbuilt function. Within this function, I pass the string in which I want to store that information. So here an example, you can just see char is the data type, str is the name, and 50 memory locations is allocated to this array of characters, that is the string. And now if I want to store some information in this, then I can utilize getas and pass this string name. So when I pass the string name, when this is executed, it displays the console, and you can enter the string. So that information will be stored in this string, in this variable str. Now what about puts? If you want to print something on the output console which is present in the string, what you do is you just pass the parameter, that is the string variable which you want to print onto the screen. So that is, you write put s, and within the function you pass this str variable. So this is what you can perform with the string. Now even I can use the scanf and printf to read the string information from the input console, and to display the string details onto the output console using the printf. So for that I have to use %s specifier. Then what are the string handling functions? So when I have string operations, right? If I have two strings, I want to copy those strings. I want to concatenate those strings. I want to identify what is the length of the string. So in order to do that, I have these functions. The first one is strcat function. So these all are inbuilt functions. So this actually concatenates two strings together. Then if I want to identify what is the length of this string, then I can use strlen function to identify what is the length of this string variable. If I want to copy one string into the other, what I can do is I can directly use string copy, or else what you have to do is you have to write in while loop or for loop, and copy each character by character into a temporary variable. So otherwise we can go for string copy function, which will copy the content of the string into another string. So then we have string compare. It basically compares the two strings, whether they are equal or not, and then it will return true or false. So these are the string functions which we can utilize on the strings. So write a program to print the reverse of a string. To print the reverse of a string. So here we need to include one new header file, that is the string.h. So which will be containing a string length, string copy. So these functions. So that is these related functions are included in this header file. So I can utilize these functions from this header file. So include all the necessary header files, and this one gives the indication that this is the starting point of the program. Then declare all the variables which are required. Actually here there should be a space after char, there should be a space over here. So then you have str variable, which is utilizing 30 memory locations, or 30 characters can be stored, including the null character. Then rev str, that is reverse string, again 30 memory locations. Then in this case, again int is the keyword. Then there should be a space over here. I and len are the integer variables. So next, by clear function, you're clearing the console, output console. Then printf, you are asking the user to enter a string. So using getters function, we obtain that information from the user into str. So here what they have done, they have written New Delhi as the string. So getters is one function which will accept this entire string. But in printf and scanf, right, the white spaces are neglected. So whatever input is entered by the user onto the console by using the input device, that will be stored in the string variable str, which is declared over here. Now, in this case, the string is New Delhi. That is the string. Now I have to type it in the reverse form. So in order to do that, what I can do is I can go ahead with the for loop. But in order to perform that, right? So if you just see how many 1, 2, 3, then 4, 5, 6, 7, 8. Total 8 characters are there. So if I include this white space, there are total 9 characters plus the null character. So there are total 10 characters which are present, including the null character. So before this, these 9 characters entirely form the string. So if in this case, what we have done is we are leaving this space. So now what we do is first we identify what is the length of this string using strlen function. So when I specify this information of the length of the string is obtained, and I traverse from index 0 up to n minus 1. If there are n characters, the last location will be n minus 1. So in this case, it will be length minus 1. So here what you're doing is for I is equal to 0. So this is the index what you'll be utilizing to traverse through the string. And the condition what you're checking is it is I less than length. So it can be I less than length, or it can be I lesser equal to length minus 1. So if the string length is just 2 characters, if the string length is 2 characters, so if you just observe what happens is I is equal to 0, 0 is less than 2, 0 is less than 2. So 2, this condition is true. So next it performs the operation, I gets incremented, I will be 1. 1 is less than 2. Yes, it is true. Again, the statements are executed and incremented. 2 is 2 less than 2. This condition is false. This condition is false. So therefore, only those 2 characters will be considered. Now here, if you just observe in this for, only this statement is part of this for loop. This is not the part of the for loop. Only this one is the part of the for loop. So for I is equal to 0, I less than length, what you're doing is reverse string, and you're specifying the index of where you want to store the details based on this information. So if you just observe here, there are 9 characters. There are 9 characters. 9 minus initial 0 minus 1. So this at index 8, at index 8, you are storing the first character. You are storing the first character of the string. You're storing the first character of the string at this location. So what is happening? So if I happen to number the locations, right? 0, 1, 2, 3, 4, 5, 6, 7, and 8. So this will make up how many this thing? This will make up 9 length of the string as 9. So the last index, if you just see, it is 8. So what I have to do is I have to take the first character of this string. I have to take the first character of this string and store in the 8th location. So that is what they are doing in this logical part. So you're taking this and storing it in the last location. So again, I gets incremented, I will be 1. So 1, whatever character is present at this location will be taken. So now what is done in reverse string, length minus I minus 1. So previously I was 0. Now if I just happen to see the value of I, value of this index, right? Length minus I minus 1, it will be 9 minus 1 minus 1, which is 7th. So this is the last second memory location. So whatever character is here, that will come and get stored in the seventh location. So these characters will be stored in this form. They'll be stored in this form. So now this will go up to what? Unless and until this eighth location is stored in the as the first character in the reverse string. It will be stored over here. In this location, this last character will be stored. So now here you got to know that the length of the reverse string is also, so that is performed in this part. In this for loop, that operation is performed. So now when that operation is performed, now what happens is now the length of the original string is also 9, the length of the reverse string is also 9. So both the lengths are same. Since you're just reversing and storing it, both the lengths are same. Now, so now logically what happens is, whenever you are dealing with strings, if you are performing operations on strings in somewhat this form, then you should compulsorily make it a point that at the end of this location, so all you have reversed now. So eighth character has come here, and the zeroth location, that is this character is come here, first character is come here, and this one has come here. Length is length is 9. Length is 9 what we have considered. So whenever we are performing operation of such kinds, right, in strings we have to make a compulsion that the next location which is there should always be stored with the null character. Otherwise what happens is there'll be a garbage, and it will be difficult for us to identify or track the end of the string when you are manipulating the strings in this form. Since if you just observe, I'm not initializing reverse string. What I'm doing is whatever is there, I'm storing this in reverse form over here. So therefore, directly I don't have the null character. If you want to include the null character, uh, but what happens is I cannot store the ninth character at the first location. That in this case, it will be a null character. So that will create a problem. So what we do is we start from this location, and then we go ahead and store all the information. And at the last location, which is given by what? If I happen to take the index, it will be 0, 1, so on, 7, 8, and this location will be 9. This information I have got in the length information. The index of this location, I know that it is at ninth location, that is index value 9. So therefore what I do is, once I perform the reverse of the operation at the end of the string at this index, that is in our case at index 9, I store the null character. So see that it is been provided within a single quote. If you're providing it within a double quote, it will be treated as a character. It will be treated as a string. So yeah, since you are just storing a character over there, you mention the details within a single quotes. So therefore, reverse string at this location you store with the null character, and then you print the information. So %s is the specifier which is used for the string related parameters. So this is with respect to, so this is with respect to reversing a string. So similarly, we can perform different operations, that using a for loop, you concatenate two strings. So all these uh, functions you can perform either using the inbuilt function, or you can use a logical aspect to perform these operations. So next, we are looking for the built-in functions. So as we had seen that in previous this thing, we use so many functions like printf, scanf, gets, getch, string length. So these were a few functions what we had utilized. So these kind of functions are already defined within the header files. So these functions are specified as the built-in functions, which are readily available for the user to utilize. So here just a few examples. In standard io.h, you have all these functions: printf, fprintf, which is used for file operations, scanf, gets, putchar, puts. So all these functions are present in this. Then we have standard library header files in which you have some ATOI, then random generator, calloc and memory allocation functions, freeing the memory allocations, exit, absolute. Then string related header file includes the string copy, string concatenate, string compare. So all these stuffs. Then in time.h, you have all these functions. In math.h, you can have sine, cos, theta, f close, f open. So all these mathematical related operations, that is the functions, are present in these header files. So these are a few to name around, which are the built-in functions which are available in C program. So already we had seen that we had utilized these header files from which, say, printf, we had used printf is in standard io.h. Clear function, what we are specifying, is actually in conio.h. Then here you can see that you're using a square root, which is actually present in math.h. So these are, and scanf is there, which is present in yesterday io.h. Sorry. So these are the functions which are present in which are present in this header files. Okay. So these are just to name around, and get ch is also present. So all these functions are present in one or the other header files. As you can see that here we haven't mentioned the conio.h and other header files. So just few we have named, and a few functions, built-in functions we have shown over here. So next, we can have some user-defined functions. These are nothing but the functions what you declare and define. For example, I want to perform some operations related to adding the complex numbers. So in that, what we can do is we can define a function which accepts numbers from the users, and real and imaginary parts we have it separately, and then we perform it by sending that information to the functions. So we'll just see how we can go ahead with user defined functions. So these are basically the custom functions which are customized by the users for some specific purposes. Now in this, some specific tasks or specific purposes, we can define these functions. Now, what are the elements which are basically required, which will be utilized to define the functions? So one is the function declaration and function call, function definition. So these are the three parameters which are required for user defined functions. You should declare a function, and you should define a function, and then if you have to utilize that function, you have to call the function, which we call as function call. So what is the syntax for each of these? The first syntax, that is the function prototype, wherein you are just declaring the function. So you're giving the information as to what the function returns and what are the parameters it will be accepting. So that information you will be providing the declaration, and apart from that, what is the name of the function? So these are the aspects what you will be providing in user defined functions. So what is the return type is specified over here. Then what is the name of the function, and within the brackets you pass the parameters. So a function can have either a zero parameters or more than zero parameters, and the return type, the function can return only one data type, or it can return void, that is nothing. The function, if it is returning nothing, we declare it as void. So next, what is the definition? What is the definition? So here what you're doing is you are declaring the function. This declaration gives you the information regarding what is the return type, what is the name of the function, and what are the parameters it is accepting. Now definition will tell you what that function will be doing. What that function will be doing. So in this case, what happens is, again, you repeat these things: return type, function name, and the parameters. And after that, you specify within the brackets all the statements which belong to that function, which belong to the function. So definition is telling you what this function will be doing. Definition will be specifying what the function will be doing. Prototype or function declaration just tells you what will be the return type, what will be the name of the function, and what are the parameters. It will not tell any other information regarding how that function is implemented, what are the statements which are present. It will not be telling that. But if you include this, it becomes the definition of the function. Now remember, you can have declaration and definition combined together. No need to have this separately and this separately. So here, if you just observe what happens is, here also you're specifying a return type, function name, and the parameters. So indirectly you're giving all the information. You're declaring the function, and along with that, you are specifying what that function is doing. So this entire thing I can club and mention that this is function declaration and definition together. So next, if I have to call a function, then what is the syntax for that? So remember, since we are specifying a return type, say if it is a returning integer type, I should have a variable of a proper type over here. So I should have a variable which is of the integer type, because whatever function will be returning, that will be stored in this type variable. So, and then you specify with the assignment operator, you take the function name and pass the parameters which the function is expecting. Take the function name and pass the parameters which the function is expecting. So this is nothing but calling the function. This is you're calling the function. Now, if there is no return type, if the function is not returning anything, then this part won't be present. It is just the function name and the values what are, or the parameters what are required by the function. So if you have to define a user defined function, you can you should have declaration, definition, and then you can call the function. So another parameter to remember is, if you have to call a function, if you have to call a function, you should satisfy that the function should be declared first. It should be declared. If you're calling a function, because C programming is structural in nature, and what happens is, first in if I just consider over here, statement 1 is executed, then only statement 2 is executed. Statement n is not executed prior to execution of these statements. So statement n will be executed when all these statements are executed and statement n minus 1 is executed. Then only statement n is executed. So this is what structural implies. That is, one after the other statements are executed, but next statement is not executed unless and until the previous statement has been executed. So in because of this, what happens is, if you're calling a function and if you haven't declared it, declared in the sense you haven't defined also, even if you define, then it becomes a problem. So before the function call, you haven't declared this function, then what happens is, it will throw an error telling that I am not able to not able to find the function. It gives the information telling that I am not able to find the function, so please check with the declaration and definition part. So these are few aspects pertaining to the functions. So this is pertaining to user defined functions. So let us see few of the example pertaining to all these aspects what we discussed, that is function call, function declaration, and function definition. So here is an example of a function prototype, or what we call as function declaration. So here what we are specifying, we specify the return type. So this one, this function is will be returning data which is of the type long integer. Then the name of this function is factorial, and it will be accepting parameters which is one parameter which is of the type integer. which is of the type integer, and then you are specifying the semicolon. So this gives you the information that the function has been declared, or this is the prototype. So instead of calling, so we'll first look at the function definition. So here you can see that we have the return type, which is long. FACT is the name of the function, and int n is specifying that this function is accepting one parameter which is of the type integer, and within the braces you are putting in the statements what you want to perform. So within the function you can declare the variables which are required within that function, then you can perform all the logical aspects. So here they are identifying the factorial. So what they're doing is, if n is not equal to 0, you are returning 1. So here you are returning a integer, a long integer. You have to have a return statement when you have a return data type. If you don't have a data type, if you don't return, then you use the keyword void. So when void is put before the function name, so here also if I put the function name before that I put a void, this indicates that this function is not returning anything. So then no need of the return statement. But if there is a return type specified, then return statement has to be utilized. So that is what is specified over here. Now we can see one of the interesting facts regarding the functions. Here you can observe that if you remember, factorial is n into n minus 1 into n minus 2, so on up to 1. So it is multiplication of all these numbers. So here if you just see, just when you accept one parameter, the next number what you have to multiply is n minus 1. So it is n into n minus 1. The next number, so this parameter is passed over here. Again, it is n minus 2. So when I take n minus 1 minus 1, so it will be n minus 2. So this keeps on continuing. So unless and until you reach n is equal to 0. So when you reach n is equal to 0, you get to know that it is 1. So you are returning 1 over here. So at the end, what you're doing is you're storing that information in F and you are returning the F value. So repeatedly, if you have to perform some operations such as in this factorial information, right? In those cases, what you can do is you can go in for functions. Now imagine if functions were not there, if you had to write these statements within the main function itself without calling a function or without utilizing the function. So depending on which number has been entered, so those many statements will be coming in for the identification of the factorial information as shown over here. So here you can see that these are the statements which will define what this function is doing. So this function is obtaining the factorial of a number. So now how do I call this function? So as I know that this function returns, if I have to call this one or this one. So yeah, I know that we'll assume that even this function is also defined. This function is also defined. So if I have to call any of these functions, then how do I call it? So I put the function name, say this one. This is the function name, and what is the parameter it is accepting? It is accepting an integer and only one parameter. So you have to pass that parameter to that function, and as it is known that it will return a long integer type, so since it is returning, I should make use of the assignment operator and store whatever the information is returned from this function in a long integer variable. So this is how I call the function. So when I encounter this statement, when the compiler encounters this one, what it does is it checks that there is a function call which is happening. So here using functions, write a program to compute the area of a rectangle. So you need to compute the area of a rectangle using a function, and So it is clearly mentioned that you have to make use of the functions over here. So include the header files which are required. Then you provide the indication of the starting of the program, and within the braces you put all the statements. Now here what you're doing is you are defining void area and two float specifications. So this is the function prototype, or it is what we call as function declaration. This is called as function declaration. Suppose if this here we are declaring the function in within the main function. We are declaring the function within the main function. So here, what is the indication? What is the return type? So in this case, return type is void. That is, it is indicating that this function is not returning anything. Then what is the other parameter? Other parameter is the function name. Function name. And next, what are the types of the parameters it is accepting? So in this, no need of specifying the variable name also in this case. You are just giving the indication what type of parameters this function will be accepting. So in this case, it is accepting two float parameters. So this is what the function prototype tells. It tells you what is the return type, what is the function name, and what are the data types of the parameters which it will be accepting and in which order. So here if it is float, here if it is int, you should be passing float number here and int number here. Now, so this is this is the prototype or the function declaration. So next you have float length and breadth parameters specified. Then clear the console. You ask the user to enter the length and the breadth of the triangle. Then use the scanf function to read those length and breadth parameters. So once you obtain the values of L and B, you pass these length and breadth parameters to this area. Now, as I had specified here, if you just see, we are assuming that here the factorial function is returning long integer type. So therefore, we had utilized this part. But here, if you just see, it is void. So it is indicating that this function will not return anything. So just you need to call it without the assignment operator. So you take the name of the function and then pass the parameters, that is the length and the breadth parameters. Since two parameters are the function will be looking for, you pass those two parameters. So you're calling the function over here. Now when you're calling the function, since you have declared it, it gets to know that this function will be defined. So it checks out and sees where this function is. So here you have defined the function. You are telling what this function is actually doing. So here you have void. So we are specifying that return type is void, name of the function is area, and what are the parameters you are accepting? You are accepting length and breadth. So these are actually variable name identifiers, what we call. These are the identifiers. So L value, whatever is there, will be stored in length, and B value, what you're passing, will be stored in breadth. So length and breadth will be having L and B values respectively. So now in within the function itself, what you're doing is you are printing the area information by performing the operation directly. So you're specifying the length of the rectangle is this much, breadth is this much, and the area is length into breadth. So within this one only, you are performing the mathematical operation. So, and then you're printing that information. So here the user enters that information, and once you call the function, what it does is it prints whatever is present in this print function. It prints that information and prints the result of the area. So here using the function, you are performing it. Using the function, you are performing this operation. So as I mentioned, if this part is not there and you're calling this, then what happens is it gets confused that I'm not able to find the declaration for this. So whether it is declared and defined, just please check out. So whenever we have to call a function, right, it has to be declared. It has to be declared. So here what we have done is we have declared the function outside. So I can have the declaration of this function outside, inside the main I can declare this function outside the main, so that if there are other functions which want to utilize this function, they can utilize it. Now this function, area function, is actually local to this main function. If any other function which is present outside this main function wants to call this, then it cannot perform, then it cannot do that. So if you have to make it global, you declare this outside over here. So you specify void area, and the parameters are two float parameters. So this will tell that this is a function which can be accessed by other functions which are present outside main also. Now here what happens is, this part, if I write it before the main, if I write it before this one, that is before calling this, here you can see that you have called it. If you write this entire part before this one without the statement, and that is not within the main, that is this entire thing, you are shifting it before the main function. So if you shift it before the main function, it indirectly, what it does is, if the function is not declared, then that is say outside the main function, then this indirectly declares and defines the function. But in that, what you have to do is, you have to specify the data type along with this parameter. That is here we have done it, right? So this also has to be included. So that is in this way. So this entire thing shifted before the main. So this will perform both declaration and definition of the function. So this is how user defined function is being dealt over here. Okay. So next we come across structures. In this one, before going into structure, we have to see what is the drawback of the array, what we have discussed previously. So as we mentioned in array, right, if we have an array, it will be allocating a continuous memory location to you, and array will store data which is of similar type. So for example, if it is a array which is storing integer type, so for example, I have something like int a, and I have specified something in this form. So here, what is this specifying? A is an array which can store up to 10 values, and those values will be of the type integer. So all the 10 values what you will be specifying should be of the type integer. I cannot store any other value apart from the integer. If you're trying to store a float value in this, it will be converted to integer and then stored. So that is one of the problems what we observe in arrays. So all these data what you are specifying, right, should be of integer. So I cannot have a float over here. This is not permitted. So if you're trying to store that, it will typecast and it will store only the integer part. It will typecast and store the integer part. So all these will be of similar data types. So this is one of the major drawbacks what we see in arrays. So at sometimes what happens is, suppose I want to store the information of a student. So what all things I'll be having? I'll be having the name of the student. I'll be having USN of the student. I'll be having a roll number. I can have say division specified. I can have the semester specified. Say I want to know what is his average of all the semesters. So here you can see that name will be a string, USN can be a string, roll number is an integer, division can just be a single character, semester can just be an integer, average can be a float. So if I have to store information which is of this kind, so here you can see that all the data types are different. All are not either integer, not either string, not either characters, not either floats. So all are not similar. So I cannot store such kind of information within an array. I cannot store such information within an array. So this is where structures come handy. This is where structures come handy. So this is the problem with respect to array, and this is how the structures try to overcome this issue. So our structures basically try to overcome the drawback what we mentioned. Since arrays can store only single data type, if I have to store data which is of different types, say if one student information, if I store it, all the information uh, will be not same data type. So in order to overcome these, we go for structures. Apart from structures, we can go for unions also. We can go for unions. So we'll check all these one by one. So what is basically a structure or a union? It is nothing but it is grouping of the different data types together. So as I mentioned, name, USN, roll number, so all are different data types. If I group it together and if I'm able to do that and use it as a single unit, then I get what we call as structure or a union. Structure or a union. So this is the definition of a structure or a union, grouping of different data types together, which form a single unit. Now, whenever we talk of structures, right, we have to look how we can declare a structure, how we can initialize a structure. So these are the two aspects what we have to look out for. Even for unions also, we have to look out for the same parameter. And we also look out how structure is different from a union. So these are the aspects what we can look out for. The syntax for structure declaration. The keyword to declare a structure is struct, struct. This is the keyword which will be utilized to declare a structure. So struct, which is the keyword, then you specify the name of the structure, and within the braces, you define the members of a structure. So all these variables what you're declaring are, we term it as members in structures. So struct is the keyword followed with the name of the structure, and within the braces you specify the members. So within a structure, I can have only one member, I can have only two members, or I can have n members over here. So depending on what all aspects are related. Suppose, for example, I want to store name and USN of a student. So this one will be a string, this one will be a string. So I can even have structure which has just single data type present in that. Single data type which is present in that. So here we declare all the members which are associated with this structure. That is whatever name is given to this with this structure. So I can end the structure over here itself, or what I can do is I can have declaration and definition of one of the variables over here. So this is how I can go ahead. Struct name members within the braces, and after the brace you can have var1 ended with the semicolon. Ended with the semicolon. So this is how I declare a struct. So this is one way of declaring a structure. Now there is another way, that is struct name. I want another parameter declared of the type structure. So this is basically a user defined data type what I can specify. Previously we saw that we have integer data type which is actually defined within the C programming itself, float, character. So these are all inbuilt data types which are declared. Now, if I combine different data types in this form, it gives me a user defined data type. So this is one way of declaring the structure. Other way is struct name. I'm assuming that struct name is already declared, that this is the declaration, struct name and where2. So where2 relates to another student, say, and where1 relates to another student. So this is how we can declare a variable which is of the type structure. So here we can see struct is the keyword, book is the name of this structure, and within the braces what you have, character, title. So this is a string which has 20 characters. So another author which has 15 characters. Then you have integer data type which is provided by the variable pages, float, the price information. So I can terminate it here itself, giving an indication that these are the members of this structure. Now, if I don't put this also, that is fine. So this gives me the information telling that this is the structure. So if I'm not specifying book one and I'm terminating the structure with a semicolon over here, that is also correct. So using I can declare the parameters associated with the structure either in this part itself or separately like this. So here what we are doing is, once we have defined the members, after the brace we are not putting a semicolon, we are giving a name over here, book one, then semicolon. So what is this telling? Book one is of the type structure, and that structure is related to book. That is the name of the structure, book. So similarly, struct book, book two. So this is the first book, book one, what we have specified. This is the second book, that is book two, what we have specified. So how do I initialize these members? So if I have to initialize, right, then how do I go ahead with that? So this is the syntax. How do we initialize it? So here you have declared. So book one and book two we have declared. So what we can do is we have to consider that variable name. So here book one and book two are the variables which are of the type structure. So structure variable one dot whichever member is there. So here in general we are considering the member one dot member one. So here you had specified, right, where one dot member one, use the assignment operator and assign the proper value. So you can assign each of the members using the dot operator. Using the dot operator, I can access each of these members using the variable which is declared for this structure, and using the dot operator I can initialize all these members. So similarly, structure variable 2 dot member 2, or I can have even member 1. So here if you just see, where 1 has n members, where 2 has his own n members. So both the members 1 to n are different for var1 and for var2. So here you can just look out. What they have done is they have specified book.title it is assigned with the characters, and book.pages is assigned with an integer value. So this is how you initialize the structure. So this is all for